Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our C++ programming series. In this lesson, we're going to be looking at the unordered multi-map. Now, previously, we've looked at unordered maps, so you can watch that video previously if you haven't seen it. And we've talked about lots of other STL data structures that are related, things like sets, multi-sets, and the difference there, or unordered sets and unordered multi-sets. But in this case, with unordered multi-maps, we are looking at a data structure that's implemented as a hash table, typically, and that will allow us to put in multiple keys and even duplicate values. So that's the difference here. So I want to go ahead and look at some of the previous examples that we've looked at and just show you that you can switch from unordered map to unordered multi-map just as simply, and it'll allow you the same number of keys. But that said, we want to be able to retrieve those keys and find some of them, so let's go ahead and look at that in some code in the examples in this video. All right, so off to our favorite website here, we're going to go ahead and look at CPP reference here, and again show you that multi-map again is a C++ 11 data structure. Let's zoom in here. So you'll need at least C++ 11 here, and in most cases you'll need or want perhaps C++ 20 for some of the nice functions like contains and so on. So again, structurally, you'll find that this is in the header for unordered map. Same thing, so you can switch between unordered maps and unordered multi-maps if you need duplicate keys. That is the difference here. So again, just to go through the description here, it's an unordered associative container. So again, whenever you see that, think key value, and then usually you're thinking about some sort of hash table implementation. And again, this supports equivalent keys being added here. Okay, so that's the idea here. And again, because we're working with a hash table data structure, search, insertion, and removal are usually constant time operations here. And again, these things, or these keys that are added into our data structure here, are not going to be sorted. If you need them to be sorted, use a map for that functionality. All right, so let's go ahead and continue on. And again, look at some of the different operations here. Now, just to give you a little bit of a brief code review of the stuff that we did last time, I created a custom data structure in Edge, which consists of 2 integer values. Again, I'm sort of thinking of graphs or maybe geometry, but for the purpose here, regardless of domain, just think of this as a custom data structure that's used as an example for this code, so we have something not trivial to work with. Here's a constructor. We have, again, another constructor or default constructor here, and then we have a constructor taking 2 parameters, and we initialize those parameters here. And then for the purpose of testing for equality, I have an operator is equal, and that, again, was important for our unordered map because we want to know if we're looking at the same keys, for instance. And then I have a useful friend function here. Let's go ahead and make this just show up a little bit nicer here for you, just for printing out elements, and you can see how that's implemented here. Again, you can check out my videos on friend functions if you need in the playlist to understand some of these different things like the operator overloads and so on. And anyways, here's our actual hash function that'll tell us which bucket to find our entries in, and that is set up as follows. Again, just something good enough for the purpose of this video here. Now, what I want to go ahead and show here is that we're just going to go ahead and switch unordered map to unordered multi-map in all of our cases here where we create a unordered map here, which I believe is just 2 here. And let's go ahead and try to give this a compile. And it looks like we have a few different errors here. So let's go ahead and look at those here and see what is going on here, or what is the difference. Now, it looks like, and it's highlighting behind me, let's go ahead and move me out of the way here, this bracket here, okay? And it's doing this for S6, S5, and so on. So let's go ahead and just look at our unordered map here. And again, this is going to be our unordered multi-map. Let me make sure I get that right every time here, and see if we have an accessor with the brackets here. Okay, so let's go ahead and see here. It looks like I can find stuff. I have different observers here. Okay, so it looks like I have the ability to find elements, but I can't access the elements here. Now, this is something important to keep in mind here because, well, if I'm allowed to add multiple entries into my actual multi-map, then what does it mean when I use brackets or .at for a key? So again, just to show this error here, or that it's not, we do have to make a few adjustments here with multi-map. And again, if you haven't watched my unordered map video or any of the map or multi-map videos, make sure you watch these. So I can't just access things as shown here. We're going to have to use find or look at a range of entries, for instance. Okay, so if I want to insert things, let's go ahead and do this properly with some updates here. Insert our pair here. S2 and edge E4. And let's go ahead and do these one at a time here. So there's one set up here, and I'll speed this up here just to make things a little bit faster. S3, S2, S3, and S4 here. Okay, so let's go ahead and see. And I believe that was the only time, and I didn't use at here. So now let's go ahead and run our code here. And now it's running just fine here. So you should see basically the same results as the previous video. Again, I'm just using insertion here. And again, why is this? Well, previously the brackets operator is actually going to insert if something doesn't exist or access if it does. And again, if I have multiple entries, I need to know which exact one that I am referring to. Now, again, just to make things a little bit more interesting here in our map here, and I'm going to go ahead and get rid of actually, I'll just leave that other one here. Let's just work with this one that consists of a string as our key in our edge, again, as shown here. Let's go ahead and, again, insertion works the same. Erasing elements here, if I have multiple elements, let's go ahead and look at the semantics of that. Usually in the STL, that just means the first one that is found, okay? So we have to be a little bit careful with that, depending on how things are getting put into buckets. That could mean the first one or the latest entry. Let's go ahead and see here. So erase here. And the default is to, if I pass in an iterator, it'll remove just the one position. If I pass in the key, that will remove everything, okay, since there are multiple entries here. Okay, so let's go ahead and create multiple entries here. So for instance, if I create a bunch of S1s, again, this will show the ability of a multi-map to just create a bunch of S1s here. We should not see S1 anywhere in this list here. Okay, so let's go ahead and compile and run this, and I don't see S1. Again, no matter how many I insert. And let's go ahead and update our documentation, remove all specific keys matching, okay, for the unordered multi-map here. Okay, so that's just a difference there. Now you might ask yourself, let's say I've inserted a bunch of keys here and I have some duplicates here. So maybe S4 gets added a few times, and let's give it some different edges here. Let's give maybe edge 2, 3, and 4 for S4. And let's print them out here. So again, we can see S4 with some different values here. How do I actually look at those? You know, what if I actually want to delete a specific one here? Well, again, since I don't really know how things are getting inserted, I mean, I could look at the source code and try to figure that out. What we have to do instead is, if we go into the documentation here, is look at this equal range here. Let's go ahead and make it a little bit larger here. So it returns a range of elements matching a specific key. So this is going to give us a pair of iterators matching the first and the last entry here. Okay, so let's go ahead and look at equal range here. And again, we've seen this in some of our STL videos here, but returns a range containing all elements with a key in that container. Because that's really what we need, this pair of iterators with the beginning and the ending here. Okay, so again, we could go ahead and see how that works here. We just go ahead and call equal range here. Now there are some different things. If you have an ordered data structure, for instance, you can get the lower range and the upper range and do some interesting things, but this is going to return us a range that matches the specified key here. Okay, whether it's the range of insertion or you know, basically what ordering we get here, I think is sort of implementation specific here. So I'll have to take a look at this. So we are getting average case linear time here. Okay. All right, so let's go ahead and try that out here. And let's go ahead and say my map dot, and I'm gonna have to take a look at equal underscore range, I believe here. And this would be a case where I probably would want to use auto here to actually, you know, it just makes it easy to get the actual type here. Otherwise, it's going to give us a pair of, in this case, string edge iterators here. So in this case, I'm just going to use auto. If someone wants, I can try to type it out. But let's just go ahead and say my range equals my map equal range. Let's see if we can pass in, and then we need to get the actual key here if it exists. If the key doesn't exist, I believe it'll just return us an empty range. But let's go ahead and pass in S4. And then let's go ahead and say, first and foremost, let's go ahead and just do a little check here. Let's say print out the number of S4s. And then we can use something that we didn't previously use and actually get the count here, okay, which is another STL feature here. So mymap.count, okay, and the key that we're looking for, S4. So let's go ahead and just try this much, see if we made any mistakes. Oops, looks like I made a duplicate here. Let's get rid of that semicolon. There we are. All right, that's better. So the number of S4s, we know we have 4 of them. 1, 2, 3, and let's see, I must have inserted another one up here somewhere. 4. Okay, so we can see the different edges here. When we're printing them out, you know, they just happen to fall in order, which is nice, I suppose here. All right, so those are 4 S4s with count, and then the actual range here. Let's actually iterate through this. So what I'm going to actually do here is just create an iterator here. Let's just call this the start equals range first, and the end equals range dot second, because again, this is a pair. So returns a pair of iterators. Okay, so let's go ahead and work with that much. So far, so good. And then let's just go ahead and say for, and then whatever our iterator is going to be from this data structure. And again, I could put this as sort of our initializer here, but we don't have anything. So I just want to say, well, start is not equal to the end, start plus plus. And then let's just go ahead and print out our particular values here. So start, this is a iterator here. So let's just go ahead and print out the start. Let me go ahead and just print out the end here. Oh, oops, let's just go ahead and do start. And since it's an iterator, we want the first field and the start, the ending field here. Okay, and then let's just go ahead and put a new line here. Just go ahead and clean this up just a little bit. And I'll walk through this again here just because we're, you know, have several levers of indirection here. Let's see, what did I miss here? Looks like I'm missing another set of these guys here. Our stream operator, let's give that a go here. And oops, this is not, and this is the second here, second element. All right, once it's working, I can actually explain it. So here's what was printed out here. And just to make this experiment a little bit clearer, let's just go ahead and put out some end lines here, just so you can see where we are at, or what I'm looking at. So the number of S4s, here they are, that I'm iterating through. I retrieve the range here, and I'm just, again, just for my own bookkeeping, I'm saying, well, here's the start, here's the first item, here's the end. Okay, so the end of that range here, which is going to be right here. And then for my start, I'm just moving this iterator that I've retrieved here and pushing it along here, looking at the first entry. And since this is an iterator, that means it's a pointer here. So whatever the first key is that I'm looking at, which is just these strings here, S4, 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 get that value, and then the second value, again, which is these edges that are printing out, okay? And again, I'm printing out these edges, or able to print these out. If you didn't catch these in the previous videos or at the very start here, I wrote a little helper friend function here that overloads the stream operator so that I can just write out the fields in my edge here, okay? And by making this a friend function in my actual edge class, I can access the private fields if I need to. In this case, they're all public, so it doesn't really matter. Okay, so let's go ahead and take a look at now just removing something here from our particular data structure. In this case, what I want to go ahead and do is let's go ahead and just take my map. And let's go ahead and just erase using iterator the start here. So whatever it points to at the very beginning here, okay? That'll delete that entry. And let's go ahead and see what happens here. Okay, let's go ahead and try to run this and see if we get just 3 S3s now at this point here. Okay, because I'm removing a particular position here. Now this is doing something kind of interesting here. So I print out the number of my S4s. Let's print out the number down here. And now I'm down to 3 S3s in this case. And it's kind of done something interesting here, where it's just, you know, eliminated my actual keys here. And we're wondering, well, hey, what happened here? Let me go back here and again delete this. I mean, this is just sort of a problem with the iteration that I'm actually doing here, in the sense that well, I've sort of, you know, what I really want to do here is do something like auto and make a copy of this start here, move start forward, and then erase the thing that I want to actually delete here. Okay, so I'm sort of this is sort of a idiom, I guess, in C++ here, where I'm saying, okay, you know, save that position, and let's actually draw this out here. So somewhere in my, you know, data structure, I've got a bunch of things here, and then I've got my, you know, S4s, and again, this is, you know, maybe they're all linked to the same bucket or something. So I've got an S4, another S4, another S4, and so on. And basically, my start is here. Okay. My end is, you know, somewhere down here for however many S4s that I've got here, right? So that's my start and then my end. And then what I want to do here is just create another copy of this. So I point here, move my iterator forward by doing ++. So now it's pointing to the next thing. And then when I iterate through, I'm just iterating through this range in my loop below. Okay, so a little, you know, trick that you can actually do here. Again, here's the end. My start is just an iterator pointing to something, and then I'm able to now use this iterator to pick out in particular element here in this loop here that I want to delete. Okay, so that was the point of that, just again show you playing around with, if you have a unordered multi-map, you can still access all the elements, and then you might want to delete a particular one. Maybe it's just the first one, this entry, or maybe you're actually searching for something more meaningful, like what is the actual value if you want to get rid of, for example, all of the keys that are duplicates but have empty values, or some discerning artifact in them that would tell you which one to actually delete. So anyway, with that said, let's go ahead and just take a quick look again at CPP reference here. That was probably the more interesting part that I want to show you in combination with the previous video on unordered map. Again, we have all the same functions. We can reserve space as has been done. We created our actual multi-map here by initializing it with some different pairs. We can use custom keys if we want. Again, you can watch the previous video to see me do that from scratch. But again, I highlighted that by writing our own hash function and our own equality operator, so we know which keys are actually equivalent in the case of us using edges here as our key, which is again a data structure that we created. All right, so with that said, again, then we explored in this video some other things that are a little bit more meaningful, like count. Since we actually can have duplicates, we use find in 2 different ways, or erase in 2 different ways, and we have find as well previously. I didn't highlight it, but we can use find again to iterate through our data structure. So all these different ways of iterating still the same here. Let me just show those again in code for the purpose of the video if you want to try those out. Again, I've left these as unordered maps, but they are unordered multi-maps. And again, as you're building these data structures, as I've done here, again, all I did was change our string edge. So this is just an alias here for unordered multi-map. Nice little trick in case you decide, hey, I actually do want duplicates in my map. And then you could just update in one place in your code, your particular data structure. And this is actually a nice way if you wanted to run different performance experiments and see which ones might be faster or slower or so on. All right, folks, so with that said, I'm going to go ahead and end this video here. If you want to follow along in the lessons and keep track of your progress, feel free to sign up at courses.msha.io. There's other great courses you can check out, FAQs, a little bit about me here, and so on. So feel free to check out those resources if you find them helpful. As always, thank you for your time and attention. And if you've made it this far in the video, let me know in the description below. And let me know if you have any questions or want to see some other features. I think this is some cool stuff we're getting into in the STL, and hope you're enjoying it. With that said, folks, I'll see you next time.